Hi, I'm Jadi and you're watching the Geeking channel. I was solving the most difficult challenge in this year's PicoCTF challenge. It is called Wizardlike with very few solves. I think 300 now. It's not very few, but consider that we have 6,000 teams here. And each team consists of maybe 5 people. So still not a high number. Very few people liked it. Maybe it was too difficult and they just give dislikes. Anyway, first, PicoCTF shout out. It's a very nice CTF. If you are interested in CTF challenges, PicoCTFs is one of the very good ones to start because its challenges are in different levels. There are very, very, very basic level challenges and more advanced ones. So, and it's can be played during, I think, 1 week or something. So you have enough time to do your research, learn things, talk with your friends, get guidance and everything. Anyway, this Wizard-like challenge was the most difficult reverse engineering challenge they had. It says, do you seek your destiny in these deplorable dungeons? So it's a dungeon game. There are mazes, you have to walk, go to different floors, but you don't need to fight anyone or anything here. Because it says, many have gone before you and honestly, they've cleared out the place of all monsters. There are no bandits there is no bounty. But it says you have to go there and find the flag and come out. The hint is here. You'd have to be a real wizard to make any progress in this sorry excuse for a dungeon. Download the game from here and WASD moves your character. Capital Q exits the game. This is the dot is a floor. This hashtag dias or whatever you call it, pound, square is the wall. This is the stairs up to previous level and this is the stairs down to the next level. As always, what we did was download the game. Most of the times reverse engineering tasks are in the Linux environment. So I copied it to my Linux machine. I'm using a Kali here. You can use whatever. You don't need to use Kali. Kali is good because it has all the most of the useful tools already installed. But for example, in reverse engineering tasks, I mainly use Radar 2, which is called R2. This is a very nice disassembler and debugger program. You can also use GDB. GDB is not created to do the cracking reverse engineering thing. It's more for debugging, although these are very similar. Also, you have seen that sometimes I use Ghidra. Ghidra comes from, I believe, NSA. If you want to convert your code to a C-like code, it's good to use Ghidra. If you want to run your code, reverse engineer it and this kind of stuff, see what exact assembly code is there, it's good to use Radar 2. Okay, first, let's run the program. Game, CD, desktop, and run the game. Let me increase the font size, make your life easier. So I can move here, that's my character. Here is the wall, I cannot go any further after the walls. I can just walk on the floor, which is a dot. So for example, here I cannot go to right anymore because I'm reaching an empty space. There is no floor here and I cannot jump. But you can see when I'm walking, some data appears here. Here is the stairs. I will go to the stairs to reach the next level. Here are the walls, very narrow way to go here, but when I'm walking I'm seeing more and more stuff on the page, but I cannot go there because walls or empty space is blocking me. So I will go to the next page. This is the next page. Again, another maze. There are ways, but I cannot go here because there is no way to go there, but I can see to some extent. So I can only go to the next level. Here I'm stuck. Very small room, no walls, just a platform and one stair backwards. If I want to go forward, I have to be able to jump or do something. I cannot traverse to this floor. My first guess was I have to do some jump here or kind of go to the next floor, and if I go further enough, I will reach a room with a flag in it. But we don't know for sure. What I did is first try to play the game, then I will try to reverse engineer, see how it works and how I can crack it. It's always good to start with radar 2 or R2. I will say cache is true, whatever. If you don't give it, that is completely fine. There are some switches you can go, you can say, I want to debug this game. I want to run it step by step. I want to write on it. I want to patch it. I want to analyze it and any other thing. You can just run it simply. It will tell you it's better to run when bit cache is true. Mastering R2 is very difficult because it's huge. If you ask for help, it will show you some helps here. As you can see, it has lots and lots of commands. This will show you the help. There are different things. For example, A, the analysis commands. So I will say A ? It will give you all possible analysis commands. For example, AA is analyze all. I can say even AA ? Is there anything further? It says yes, AAA. Automate functions after AA. Okay, AAA ? No more answer. So I will go with enough A's. It will analyze the file. Now it had read into the file, seen the functions, variables and everything, and now we can have a look of what is going on. One very famous one is AFL, analyze functions, list. AFL, analyze functions, list them. These are all the functions which this program has. It's a big program. See, one is entry 0. Program starts from here, then goes to main. I can say seek to entry 0. Now I'm starting at the beginning of the program. If I say V, it will visualize what is going on. In this level, it's exactly like the bytes which are in the program. So in the beginning, it is F3. Let me see, why it's changed. Line tool. I don't want lines, I want just normal brush tool. Okay, now it's okay. F3, 0F, whatever. This is beginning of the entry, not beginning of the exact file. So, if I push, I entered this with a capital V. If I push P, I will change to different views. This is only the assembly code. Another P, now I have stack, I have registers, and I have the assembly code. And this is changing to the... I can go with another P. Now, this is a representation of the commands and bytes there. You can see that there is a function defined here on this address. Then there is one here. There is function here. There are different things, and you can go forward and have a general look at the kind of entropy of the commands. At the beginning, I started from here because I scrolled down. This is a normal program, but suddenly you have this. From this address on, 2074 or 5, 1, 2, 3, 4, 5. So from 2075, it doesn't look like a program anymore. There are some other data here. So what I did was I wrote a small Python program. It would read all the binary, write all the binary up to here, and I could look at what I have here. The fun part was these consists of some zeros, some dot characters, some of this, a couple of these. So this is the map part. What I did, which I really liked and unfortunately didn't lead to anywhere, was that I started writing all the characters I've read into another file up to here. Afterwards, I started reading these and writing them into the new file, except a small logic. I exchange, for example, 10% of floors with next level steps. So I was creating more next level entrances. It was much easier to go through the maps. I was thinking maybe if I go 10 levels deep, I will see the flag, but it didn't happen. This worked and was very cool, but I was able to replace some of the spaces with dots. So I was creating new floors. I was able to walk around the maps, but nothing fancy happened. So I continued on another way. AFL. These were our functions. The logic of this program should be, there is a program here. Why this is happening? Then there is a map here. So technically, most probably part of the program, which is the main, you can see it's kind of huge. Not huge, but big enough. What it does, it seems it's, this one. It seems that it reads the map, prints it, reads your input characters if you are pushing any of the QSWA to move around, or Q, deciding where you should go and if it changes the map or not. So one of these functions should be responsible for deciding if your character can move or not. I was looking for this. It is not very difficult. It's enough to seek to any of them. So the pointer will go here and then go with V, and you will read the code. For sure, there are very, very few people who could just look at the assembly code and say what it does. But after a while, and if you know assembly, you will be able to see patterns. I will show you. There is no secret thing here. When you are doing the cracking, it's not like keep the shift while booting the system and you will have some specific tools. You have these tools. You have the debugger, you have disassembler, you have the sourcer. But at the end, it's your experience which helps you to see what should be done, if this is the part you are looking for or anything. For example, let's have a look at main. I can go seek to main, V, show me the code here. I'm here, I don't like it, I will push P, not this one, not this one. This is good. This is the general logic of the program. You can see it initializes something, then calls a function, went back, calls another function, does different things. Anyway, if I wanted to see what it does in each instruction, I would go with running it, F7 to step on the functions and this kind of stuff. But this is not I'm going to do. At the first, I was going to look into different functions. For example, this one. I started from the larger functions. I would copy this. So I would say seek here and V. Let me show you. V is showing me the exact assembly program. It helps you to understand it better by using some jumps. For example, says it will compare EAX with this variable. Lower or equal jumps here. Otherwise, it would do this. Interesting. It will check this one with this one. It would jump here. Then I have a larger loop here. See, you can see the patterns and what is going on. This is lots of loops in each other. I would say this is kind of deciphering the map and showing it on making it ready to be shown on the page. This is too huge for controlling. AFL. The next one was this one, and this is what we are looking for. I would go with seek to this address. I can go with v, which shows me this. Here, when I'm looking at this, it is obvious that there are lots of ifs, and all of them is saying, if this happened, jump to there. If this happened, jump to there. If this, jump to there. If this, jump to there. If you are too close to a wall, if you are on a floor, if you are on this, if you are exiting the map, whatever. This looks very nice. But you even have a better way to look at it. If you go with VV, it will show you the program like a flowchart. See? This is much nicer to understand whole structure. There is some logic here, does something here. Why are you becoming like this? There is some logic here. It says if true, go somewhere. Then check this. If true, go there. Then check this. If true, go there. Where it goes? All of these go to here. Moving 0 into EAX. Again, if all of those were not true, check this one. Check something with 0. If true, move 0 to EAX. Otherwise, do another check. If it's true, again, move 0 to EAX. See, it does a lot of checks. In each case, it is moving 0 into EAX. If none of them, it's moving 1 to EAX. It's very, very, very close to what I would write to check if we can move to that specific location or not. You can push another P. It will show you a little bit more compact version of the same thing. If you are into these kind of things, it's very obvious. It's a check. If it's true, this. Then check with something else, if true, this. Then check with something else, it's true, this. Then check with something else, if true, this. It's exactly like this. If this, and if this, and nested if. So, what it does check. This was my first guess, and the reason that I started looking into this. But let's read the code, and you will see that it's even more interesting. First, it has two arguments here. Argument 1, argument 2. Also, two variables. And what it does, first, it compares the first variable, with 0x63. If you are into these things, you quickly know that 0x64 is 100. So this is 99. It is checking something, seeing if it's a jump greater, if it's greater than 99. If something is getting larger than 99, it goes and sets something as 0. On the next step, it tries the next variable. See, first it checks the first variable. If it's larger than 99, goes to that make return back function 0. Then checks the other variable with 99. Still, if it's larger, it will say, okay, answer is 0. Then it checks if it's smaller. It compares the first variable with 0, jump if smaller. So if it's true, if it's smaller than 0, set something to 0. If the second variable is also smaller than 0, set the variable to 0. Otherwise, it just starts checking more things. So, what it's doing, kind of clear now. It has a playground. It starts with x and y, x and y, as you guys say. 100, 100. It is checking if my x is smaller than 100 and is bigger than 0. So I'm in the game. If I'm here and if my x is going to be -1, it returns back 0. Also, same thing happened for y. If y is larger than 1 and smaller than 100, let it go. Otherwise, set the return back function to 0. So this is a function which checks if the player can move here. Another very, very cool clue is the next checks. If x and y are in 0 to 100, this part starts. It does something, reads something, do something, add something, kind of deciphering something, and then says compare the result with 0x23. If you don't know what is it, it's easy to check. Just go to IPython 3, for example. What is going on? Ow. How should I turn the caps lock off? IPython 3, because I'm using caps lock as a backslash, and if you push it with shift, it works as caps lock. So you can say print. Ow. Okay, this is 35. What character is 35? You can check with CHR of 35. And it is your DS hashtag square pound or whatever you call it. So this is the wall. So what the program is doing, it's checking if X and Y of the player is in this area, not bigger, not smaller. If where you are moving, comparing it with a wall, if it is a wall, it goes to 0, setting the variable to 0. If not, it does the same things, gets the character, checks it with something. At the end, it says check it with 0x20. Everyone knows that, not everyone, but if you play this enough, you will know that if you do any hex things or ASCII characters, you know that this is equivalent to 32 in decimal, which is a space character, or as better, easier to see, this character, space. Okay? So, what it is doing? It is checking X and Y to make sure it's in the playing area, 0, 0, 100, 100. And then checking if where you are going is not this and is not space. I didn't decipher all these things. I just checked what is it comparing it with to. And when it's comparing with this and this, it's obvious. It is checking if the character can move to this place. This is a pattern which happens in many, many, many cases. Even if you are doing electronics, you are not checking every single capacitor and resistor. You will look to the board and you will see, okay, this is the power supply. These are the outputs. Where are the outputs connected? So this is multiplying something. This is a receiver. You are seeing in blocks. Here, I also don't need to understand the whole thing. At the end, I see, okay, it had some variables, checked it with 0, checked it with 100, then checked if it's this character or this character. So it's checking if my character can move there. At the end, all those you cannot move there came to this one. And one same block above. I will show you. Otherwise, if you are in the area, if you are not going to the wall, if you are not going to space, then move one into EAX and they will both jump here. Super cool. I will just show you the other block. Let me make the font smaller. This is much better. So these are all the checks. If you cannot go there, this is you. So you will move EAX 0, 0 into EAX. Again, if you are going into the wall or something, move EAX 0, move 0 into EAX. If you can move there, if you are, it's not a wall, it's not a space, you are not going out of the boundary, you have move EAX 1. Then you go to the last part which returns the function. Most probably this is a function like, can I move there? Gets X, Y, and your place. Doesn't get it, it has it. Anyway, so what can I do to trick this? It's enough to tell to all of these to return 1. Whatever happens, say, yes, you can move there. This is one way. You can do it in different methods. You can make this function just to return back 1, whatever. But I'm not interested in challenging in writing different function or anything, so it's easier to me just to see what these lines has and change them to these. I will push another P. I want to see the opcode and assembly code. This is it. So for example, here, this is the machine code. This is the assembly code. This is the address in which this code is written. You should know, machine code is 100% translatable to assembly code on this machine. Whenever you have move EAX 0 in this logic, you will have B8, 1, 2, 3, 4 pairs of zeros. This is the equivalent. This is 1 to 1. Practically, these are the same thing. If I could show you the Pam's meme, which says these are essentially the same thing or something like this. On the other case, for example, this one, when you are saying move 1 into EAX, it says B8, move to EAX, for example, 0, 1, 0, 0, 0, 0, 0. And this is a jump. And then it jumps to the EB05. It means jump 5 locations ahead. So it jumps here. In my disassembler, it disassembled it to this one. So for example, here I will have EBC. So it will jump C locations ahead. That would be this one. This is calculated. But here I'm not sure what is written in the program. I can switch back to 1V and see the actual code where I wanted to do my changes. It was here. This was the logic. This is the exact if I told you. It checks. If it happens, go here. If not, go here. If it happened, go here. If not, run these and then reach there. And this is why. This is C, because it is jumping here. And my other jump, which is 0.5, which jumps here. Anyway, I have these in my source code, right? I want to change this move EAX0 to move EAX1. So every time I'm reaching here, even if I'm reaching here, I will return back 1. On R2, it's very easy to edit code. But I'm old school 90s kid, so I would go with a hex edit. Old school, lovely hex edit. And you will see 2 tools. So what I want to change is B8 00 00 00 00 00 EB0C B8 01 00 blah 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 and another B8 0. It's enough to change these two, right? This one and this one. It is possible to come here. I don't have write flag run here. I should run R2-W to be able to write. But if I would do, I could do this. I just push A. It will tell you, okay, give me an assembly code. I will say move EAX0. It would say, okay, the equivalent opcode is this one. Enter, save the changes. Yes, it's saved. So I didn't want a W. Anyway, I changed one of them. I will exit and another exit. This is what I wanted to do. I wanted to run the hex editor on the game. Control W will search. What I wanted to search for was this one. EB0C. So B8, this used to be 00 00 00 00 00 EB0C. Ah, I found it. So that change didn't work. I don't know why. Anyway, so I found it here. This is the equivalent opcodes. You remember EB0000 and then, sorry, B80000, EB0C, then the one which was returning the correct value if you can move there up to here. If this happened, BE was move. This was EAX01. And then this was a jump 5 ahead. Anyway. And then I had this check. This check, again, move 0 into EAX. Then jump here. This is it. Okay. I want to change this to this. On the first condition, put 0 there. Sorry, put 1 there. This was the second one, so putting 1. This was the third one, which was you cannot walk on the floor. And we will put a 1 also here. So this should work. Now I have patched my binary on the hex opcodes, machine code, but I know what the equivalent assembly is, and I tried to show you in the most possible details I could, because I love if you learn these things and enjoy these games. And this is what we use in real world to reverse engineer a binary. Also we use in reverse or word to break software if it is legal. Never do illegal things. It can lead to huge problems. Don't do it. Just learn and understand. This is for making your knowledge deeper and deeper. Anyway, we patch this. I will do the exit. This is my exit. Even if now I go with radar 2, I know what I'm doing now. I have this, I have this. I can say seek to this function, which I have already seen, and then say VV. You will see that it says if this happened, move 1 into EAX. This means if I was going out of the boundary. This one says if I was moving on the walls or going to the space, put 1 here and put 1 here if not. So now in each case you can walk there. Now QQQ will exit. And now we will check. You can walk on space, you can pass walls, and you have the answer here. Very interesting. So the answer is why this is happening. The answer is PicoCTF. This open, nothing else on this floor, so I can walk and go to the next floor. Here I will go here. You can see that we are revealing more data. This is lit. If I make the characters smaller, it would be easier to read, or maybe not. But anyway, this is a lit writing for you are a wizard. This is how hackers write. This looks like a something later, maybe on the next floor. If I move to the next floor, there is a 1 here, so I should add 1 to my flag. So I will have 1 here. Then we have this. We can walk on the sky, so we can go here. 4. So this was 1, 4. These are the rooms we have not seen before. As you can see, there is a 9 here. I went to the previous floor or the next floor. I don't know. Where am I? I went further than 0. Now that we know how the program works, we can patch that. Anyway, You will go to the next floors and find more and more rooms. Where is this number? Okay, 19 here, and you should go to next room and next room and next room and find. So, what I wanted to show you was, it is easy, it's time consuming. You have, maybe I spent 2 hours on this, and you have to learn assembly code, and you have to be patient. Go step by step, write things down. Normally, if I wanted to, I'm exiting this. When I was playing, if I would not find it very quick, I would copy paste all these functions into a text file, and from that text file I would go one by one, so I would know which one I have tested, which I have not. I would write notes and everything, but have a general glance at the first to everything, and then after a while you will start finding clues. This was a difficult one because you should see those nested ifs and conclude that, okay, this is a if I'm in the area, if I'm not on the wall, if I'm not this. Anyway, hope you enjoyed it. This was Jadi. I would be very glad if you subscribe. That would give me more hope to continue the channel.